This is part 1 of the Parallel Lines Flipped lesson. So we started with definitions in our class, and we are now going to add to those definitions some more geometry terms. When you have two coplanar lines that do not intersect, or even more, but as long as the coplanar, meaning lying in the same plane, those lines do not intersect, we call those parallel lines. An example would be two lines like this. Typically you recognize them because they would have little arrows in the center of them, meaning that they are parallel. If we called this A and this B, then we could use symbolic notation that line A is parallel to line B. Then you also have lines that intersect at right angles. Those are called perpendicular lines. For example, if these two lines intersect and we know they form a right angle, we call them perpendicular lines. So let's call this M and N. The way you show this symbolically would be that line M is perpendicular to line N. It's like an upside down T. Additionally, we got more angle relationships. If you have two angles that have a sum of 90 degrees, that means their measures added together are 90 degrees, we call those complementary angles. Okay, so for example, let's say we've got this. We know it's a right angle, and we've got angle 1 and angle 2 here. The symbolic notation that we could use would be to say that the measure of angle 1 plus the measure of angle 2 is going to be 90 degrees. When the angles add up to be 180 degrees, they have a sum of 180 degrees, we call those supplementary angles. For example, they would make a straight line. And we could say that this would be maybe measure of angle, let's go 3 and 4. So our symbolic notation would be that the measure of angle 3 plus the measure of angle 4 equals 180 degrees. That makes them supplementary. We do get some angle relationships, especially if those lines are parallel, because then they allow us to say certain angles are congruent and certain angles are supplementary. If you have a figure that's formed by two lines and a transversal, then it creates pairs of angles. And the pair of angles, if they lie on the same side of the transversal, so maybe they'd both lie on the right side of the transversal, one is in the interior and then one is in the exterior of the angle, but they have different vertices, which means they have different vertexes. We call those complementary. Or I'm sorry, not complementary. Let's try this. Corresponding angles. We already did complementary. Corresponding angles. So for example here, we could say that angle 2 and angle 6 are corresponding. Or we could even do, there's one on the interior, one on the exterior, angle 4 and angle 8. Looking at this side, it could be angle 1 and 5. It could be angle 3 and 7. Those are corresponding. Now, if you know for a fact that these lines are parallel, then it adds in some new relationships where we can say that those are actually congruent to each other. Another set of angle relationships. A pair of angles in the interior of a figure formed by two lines and a transversal. So here we have two lines, a transversal. We're looking at angles that are inside only, but they lie on opposite or alternate sides of the transversal. They have different vertices, which means this and this, they wouldn't be touching. These are called alternate interior angles. So for example, in our diagram here, 3 and 6 are on opposite sides of that transversal, so they're alternate interior angles. And angle 4 and angle 5 are on opposite sides of that transversal, so they're alternate interior angles, both inside those parallel lines. Next, we have a pair of angles in the exterior of a figure. They're formed by two lines and a transversal. So here are your two lines. Here's the transversal. They're on the outside. They're on alternate sides of the transversal. They have different vertices. Those would be called alternate exterior angles. So for example, in our diagram, angle 1 and angle 8, and angle 2 and angle 7 would be alternate exterior angles. We can also have a pair of adjacent angles whose non-common sides are opposite rays. So, for example, let's look at this one. Here's these two angles, and the side that they do not have in common, this one they have in common, so the sides they don't have in common, which would be this side and this side, are opposite rays. What that makes is a pair of supplementary angles. Or, what we can say is that if we've got them having non-common sides with opposite rays, we have a linear pair. They form a line. So in this case, when we're looking at this, and based on the way sentence structure, I should have just stuck with the linear pair because of the sentence structure. When we have non-common sides here with our rays, we say that they make a linear pair, which means that they essentially form a line, which would allow us then to eventually say that they are supplementary, which means that their measures would add up to be 180. So sorry about that. With the sentence structure, let's go with a linear pair. Oh, and I should have given you examples. How about like angle 1 and angle 2, or even like angle 1 and angle 3? Okay, so angle relationships. For two lines intersected by a transversal, so two lines cut by a transversal, we have a pair of angles that lie on the same side of the transversal, so they're both on this side or they're both on this side, and they lie between the two lines, which means they're on the inside here. We would call that same side, and since they're inside, we would say interior. So for example, angle 4 and angle 6 are same side interior, and angle 3 and angle 5 are same side interior angles. It's important to say that if these were parallel lines, these same sides would not be congruent, rather they would be supplementary, meaning they add up to be 180. And finally, the non-adjacent angles formed by two intersecting lines are called, so essentially, if we have two lines, and they're the ones that are not side by side, that would be like across from each other, we're going to call those vertical angles. So for example, angle 2 and angle 3, angle 1 and angle 4, angle 6 and angle 7, angle 5 and angle 8, and so on.